welcome my dear student. So this is the problem from the book DC Pandey. He says that there is a particle of charge plus q and mass m is moving under the influence of uniform electric field which is acting along the x direction given as EI. And there is another magnetic field that is there, that is B, which is acting along the z direction BK. So B is acting in the dot direction and the electric field is along the x direction. And the particle is thrown from point P and it follows this trajectory PQ and comes out from this region with a velocity of 2v in this direction. So it is injected in this field with a velocity of v, and finally it will come out from the velocity from the x-axis direction. In this direction it is a velocity of 2v. Now, which of the following statements are correct? So you are asked to calculate which of the following statements are correct. So first, the question is that calculate the electric field magnitude. So in this situation, only the work is being done by the electric field. No work is being done by the magnetic force. Why? Because on this particle, the magnetic force will be acting in this direction. Fm will be always perpendicular to the displacement direction. So magnetic force, work done by magnetic force is always going to be 0. So whatever the work that has been done, that is only done by the electric force. So using the work energy concept, what you can say that total work done, that is equals to the work done by the electrostatic force, that should be equal to a change in kinetic energy, delta K. So what is delta K? That is equals to half M into 2V whole square minus V square. That means 3M V square by 2. So that is our total work done by the electric force. Now, on the charge particle, the force of electric force is how much? If I say the charge is Q and electric field is along the x direction, so charge multiplied by electric field, that is the force. So force is E into Q. And what is the displacement? Displacement is 2A. 2A is the displacement along the x direction. Why? Because the force is along the x direction. So 2Q, E into Q multiplied by the 2A, that is the work done by the electric force. And that should be equals to what? Pm V square by 2. So from that, if I calculate, then it means I am getting E equals to Pm V square by 4 times Q into A. Okay. So that is the magnitude of the electric field. So the first option is correct. Now, it is asked that the rate of work done by the electric field at point P is how? So work done by electric field at point P should be equals to then force dot or displacement. So rate of work done is, that is the power. So force dot velocity. Dot velocity vector. Now at point P, velocity vector and force vector are parallel to each other. That means that is nothing but our V cos 0. Cos 0 degree. That means it is equal to F into V. Okay. So F is what? F is basically E into Q into V. That is your answer. Now what is the value of E? That I have already got it as equals to C M V square by 4QA. That is the E magnitude multiplied by Q into V. So ultimately I am getting C M VQ divided by 4 times A. Okay. That is option B is also correct. Okay. Now if B is correct, then C is incorrect. Why? Because it has been said that the work done by the electric field at point P is 0. Now you are asked to calculate the rate of work done by both the field at Q. What is that value? So at point Q, what is I can say at point Q, the electric field is in this direction. Electric field is along the x direction. So corresponding the force is in this direction. So F Q is equals to how much? Q into E. But now the velocity is vertical. So what is the angle between these two? That is 90 degree. So work done, rate of work done, that is the power. So that should be equal to how much? F vector dot V vector. That is 2V vectors. But the angle is 90 degree. So dot product becomes 0. Okay. So the last option is also correct. So only A, B, D options are correct. Okay. So hope you understand this. Thanks for watching the video. If you like it, please subscribe my YouTube channel.